Okay, second day of completing the square. We're going to do with a coefficient the value of a not equal to 1, and then we're also going to do vertex form. So there's two things in this lesson. First off, is this funny? I just completed this. I think the math guys will love it. Completed a square. Okay, just a little recap if you remember what we were working on here. The big thing is going to be, we're going to complete the square, so I'm going to move the constant to the opposite side, x squared minus 8x, then I leave this blank, and then this is the big move now. We are creating a perfect square trinomial. This will be x. Remember, this is divide by 2, and this is square it. And whatever I add there, I gotta add there, and I get the big deuce over there. So then when we take the square root of both sides, don't forget the plus or minus, x minus 4 equals plus or minus root 2. Add 4 to both sides, x is 4 plus or minus root 2. This is exact value, and now we could get decimal equivalence by actually adding those, and what that means is that's where we would cross the x-axis. Okay, now we're going to go when the leading coefficient is not 1. So basically, we're going to get that constant term to the other side. I'm going to divide everything by 4, and I'm going to get x squared plus 6 over 4, or 3 over 2x blank equals 3. So all we're going to do is we're going to divide through by a. So that's really the main thing. Now here's a quick tip for you though. When I divide a fraction by 2, 3 over 2 divided by 2, that's the same as 3 over 2 times a half. Half of 3 over 2, half of 1 1/2 is 3/4. So I get 3/4. And then when I square it, I got to square the top and square the bottom. And over here, I square the top and I square the bottom. Pro tip, I'm a professional, okay? You want to put this into over 16, okay? So this is actually 48 over 16 plus 9 over 16. You're going to want to do it as a fraction. Some of you are like, I hate fractions. That's okay. Because when you do it as a fraction, look what happens every time. This number on the bottom is always going to be a perfect square. And when I take the square root of a fraction, plus or minus, don't forget the plus or minus, I take the square root of the top and the square root of the bottom. And that's the beauty when you have a fraction over there. That's always going to be a perfect square. So now I get x equals, I subtract 3/4 from both sides, and I get negative 57 over 4. I've got a common denominator. I could turn that into negative 3 plus or minus square root 57 all over 4 if I really wanted to, but we're fine right there. Oh, and then there's where it ends up crossing on the x-axis because that's what we're finding here. Okay, again, I'm gonna add the 1 over, and I'm gonna get 3x squared minus 2x equals 1. I'm gonna divide by 3, divide by 3, and divide by 3. And I'm gonna get x squared minus 2/3 x blank equals 1/3. And now I'm gonna complete the square. And this is the big moment now. I divide this by 2. And now again, some people I often get them, they're like, oh, it's times a half, it's 2/6. Well, half of 2/3 is 1/3. So I get minus 1/3, square the top, square the bottom, square a negative, you get a positive. Add 1/3 to this side, or 1/9 to this side. This is 3/9 plus 1/9 is 4/9. Oh, 4/9, that's nice. That's nice. Plus or minus, x minus 1/3 equals plus or minus. Square root of 4 is 2. Square root of 9 is 3. Oh, look at this. Look at this. I add a third. I add a third. Look at what happens here. X equals 1/3 plus or minus 2/3. Don't leave it like that. Actually do that. 1/3 plus 2/3 is 1. That's 3/3. And 1/3 minus 2/3 is negative 1/3. Whenever I get nice values like this, that means my original function would have been factorable, okay? Now we wanted to do it with completing the square, but I could have done 3x and x, and then negative 1 to get negative, this would be minus 1 and plus 1. And now if I set these both equal to 0, this one would end up being x equals 1. This one would end up being x equals negative 1/3. Another example about how factoring is really the fastest way to do it if you can factor. Okay, move the 15. I guess move the 15 over, and now divide everything by 2. X squared plus 11 over 2x blank equals negative 15 over 2. And I'm going to leave that as negative 15 over 2. I'm not going to do 7.5 because I'm going to need a common denominator there in a little bit. Again, 11 over 2 divided by 2. If I'm dividing by 2, I'm multiplying by 1/2. So this is 11/4. Square it, 121/16. Add it to the other side. We have to maintain. So remember, what we're doing here is we're creating this perfect square trinomial that then turns into this binomial squared. That's what completing the square is, right? And now 16ths. Oh, I'm going to need a calculator because I'm going to need 15 times 8 is negative. Oh, this is going to work out nice. This is negative 120 over 16 plus 121 over 16. Ah, this is great. So I did times 8 times 8. That's where I got this common denominator with 16ths. And then I get 1/16, and I square root, and I square root, and I plus or minus. X plus 11/4 equals plus or minus. Square root of 1 is 1. Square root of 16 is 4/1/4. Minus 11/4 minus 11/4. X equals, now I can do this, negative 11/4 plus or minus 1/4. Well, let's actually solve that. Negative 11/4 plus 1/4 is negative 10/4. Negative 10/4 is negative 5/2. And then negative 11/4 minus 1/4 is negative 12/4. That is negative 3. Again, this would have been an example that also could have been factored. This could have been factored from the get-go, and but there's more than one way to skin a cat. Okay, next we're going to do vertex form of a quadratic equation. And we remember this from our transformations. The h takes us left or right. The k takes us up or down. The dilation flips it over the x-axis and makes it wider or narrower. Okay, so we have to remember a times x minus h squared plus k. So if you remember what happens here, this is going to be down 1, right? This is going to be up 1. And if we look, there's g of x, down 1. There's h of x, up 1. Look over here. Remember, it's the opposite idea. This is 2 right. This is 1 left. This is 4 left. Okay, and here's my original. The red one is 2 right. The green one is 1 left. And the blue one is 4 left. Okay, oops, these got a little bit out of whack, but remember, this should be the H, and this should be the K. So this is going to be left 1, up 1. So if we check that out, the g of x function, left 1, up 1. Now this x minus the value 2, remember it's an opposite idea. So this is right 2, up 6. Right 2, up 6. There it is. The last one, this should be left 2, because the value of h is actually a minus, and then because the minus is part of the formula. Very important. And down 3. Remember, inside the parentheses left and right, outside the parentheses up and down. So there's left 2, down 3. Dilations, this one will be narrower or go up faster. So we'd say narrower, narrower, or faster. This one would be wider. This one would be flipped because of the negative, and narrower. And this one would be just flipped. And it's flipping over the x-axis, yes? There we go. Yep, we got them. Okay, when a is greater than 1, it's going to be thinner. When a is less than 1, it's going to be wider. When it's negative, it's reflected over the x-axis. Write the function in vertex form. this is going to be slightly different. This is not equal to 0. Here we go. If you're going to pay attention today, pay attention right now. 1, isolate the x terms. We have 2 x terms. I need to get them by themselves. 2, complete the square. To find x minus h squared. So I'm going to leave a space here. You got to leave a little space. And I'm going to go divide by 2, -1, square it. Big moment. Plus 1. If I add 1 over here, I have to remember to add 1 over here. And that's why we need that little space. This is y minus 3. That's the most commonly missed piece in this one. And 3 put into vertex form, which is y equals a times x minus h squared plus k, which means I add 3 to both sides, and I have y equals x minus 1 squared plus 3. The vertex is at h and k. +1, +3. This would be 1 right, 3 up. That's where it would be on the graph. This is a great way to find vertex form and graph a function. Oh, I covered everything up. I'm going to erase so that we can do this next one. You okay with that? Okay, great. Okay, now we've got this -3. So again, the first thing I do is I subtract 10 from both sides, and I get y minus 10 equals. Now, we need to factor out the value of a, which is -3. I factor out a -3 and get x squared plus 6x, leave a blank. All right, here we go. Leave a space. And now I'm going to complete the square. X, and I go plus 3, and I square it, and I go plus 9. Stop right there. Stop. Everybody stop. What did I really add to the right-hand side of this entire equation? Did I add 9? Nope, because technically this goes back in here, and it's technically -3x squared minus 18x, wait for it, minus 27. So what I really did was subtracted 27 from the right side, which means I need to subtract 27 from the left side, and I get y minus 37. Okay? That is the most difficult thing that you will do today. I had to factor this value of a out, and I'm making this perfect square, but I have to think about the fact that in order to maintain equality, I distribute this -3 in, and that's really a minus 27, okay? And that's what I did to the other side. I did a minus 20. Because if you do a minus 27 on this side, in order to maintain equality, I do minus 27 over there. Add this over, y equals -3 times x plus 3 squared plus 37. This is going to open down. It's going to be reflected. It's going to be narrower because of the value of a is -3, and it's going to have a vertex at 3 to the left and 37 up. Right in vertex form, I would minus the 5 over y minus 5 equals x squared plus 6x. Leave a space because I'm going to add to both sides. Create the perfect square, divide by 2, square it. I really added 9. There was no value of a there, so I'm just adding 9. Adding 9, y plus 4, subtract it over, x plus 3 squared minus 4, vertex at -3, -4, and my answer looks like is right here. What is the equation for the graph? I'm going 2 right and 3 down. That's going to mean 2 right is going to be minus 2. That's all of them. 3 down is going to be minus 3, so it's not that one, and it's not that one. Then I just need to figure out, is this wider or narrower? I believe it's wider, but I could check. How could I check my work? Pick a point that's not the vertex. How about 4, negative 1? When I put a 4 in here, 4 minus 2 is 2. Squared is 2. 2 times a half is 1. Minus 3 is negative 2. Is this 4 negative 2? It is. If I put a 4 in here, 4 minus 2 is 2. Squared is 4. 4 times 2 is 8. 8 minus 3 is 5. So if it was this one, I would be at 4, 5, 5, and that doesn't work. That doesn't work. Or this is 4, negative 1. Did I get that right? 4, negative 1? Yeah, 4 times a half is 2. 2 minus 3 is negative 1. Almost made my first mistake of the year. Next one, which is this? It's opening down. Boom, I'm done. Okay, you can check the rest of it. 1 left, 2 up. That's right. And then it's narrower and it's opening down. None of these are negative. Okay. Try this one on your own. I'd hit the pause button. Try this one on your own, and then I'll do it. Pause. Y minus 1 equals, now I'm going to factor this. Factor. Negative 2 comes out. X squared minus 2x blank. Leave a space. Complete the square. X minus 1 square. Divide by 2, square it, plus 1. Big moment. What did I really add to the right side? Did I add 1 to the right side? Nope. I actually did minus 2. Y minus 3, add 3 over. Y equals negative 2 times x minus 1 squared plus 3. Now we're going to graph. My vertex is at 1, 3. 1, 3. I'm opening downward, and I'm going to go zoom, zoom. Hey, can we use our skills back from 3, 1? Yep. What's the y-intercept? The y-intercept is when x is 0. 0 plus 0 plus 1, so I know 0, 1 is still there. You can still use those. I got symmetry. I got symmetry coming down here. I'm going to also be there. If I really wanted to, I could plug another point in there, but I believe we're good. Whoops, I'm not making it look very rounded, but it's okay. It's fine. Okay, move the 8. Factor out the value of a. Leave a blank. X, divide by 2, square it. Plus 4, I really did plus 12. Very important. Y plus 4. Y equals 3 times x plus 2 squared minus 4. I move that back. Okay, which one is left 2, down 4, and narrower, and opening up? Got to open up, can't be that one. Left 2, down 4. That one's the left 2 and down 4. That's not left 2 and down 4. That's not, it's B. It's got to be, because I know it's left 2 and down 4. Okay, last thing for today. We're going to start in vertex form, a times x minus h squared plus k. This is h and k. This is x and y. We need to solve for a. The y is 0, and the a is what I'm solving for, and the x is negative 3, and the h is 2 squared plus k. 0 equals a times negative 5 squared minus 4 plus 4. Now I'm going to minus 4, negative 4 equals a times 25. Divide by 25, divide by 25. A is negative 4/25. Write the equation in vertex form. Y equals a times x minus h squared plus k. Boom. So you're given an h and a k and an x and a y. I put the H there, I put the K there, I put the X there, I put the Y there. And then you solve for A like a normal algebra problem. And then you rewrite it with your A, your H, and your K. This one would be 5 right and 100 up. And you wouldn't be able to graph it on this. And then it's going to open down. And I believe if you graphed it and you went 100 and you went 1, 2, 3, 4, 5, you get a vertex there. It goes through 0 and it's symmetrical. And it looks like this. And this is the 5, 100. So it's 5 right, 100 up, flipped over, and narrower. Okay, we got a little worksheet, I think, and we have a couple of books problems for lead term, not 1. Right on. You knew X was 7 the whole time. You're darn right I did. Good times. Good times.